Alright, here we go. So I've officially procrastinated this video long enough. It is officially 8:47 on Sunday night, and this needed to be done about 2 days ago. But we'll get through it here, so bear with me. This should be relatively reviewed, but we'll see how it goes. Section 2.1, quadratic functions. By the end of this, you should be able to analyze graphs of quadratic functions. The word quadratic essentially means squared, so it's a function that has a degree of 2 in it. Generally 2 is the highest degree. Write quadratics in standard form, something we're going to do a lot of work with today, and then write the equation of a parabola or a quadratic given 2 points. Alright, the book definition, the quadratic function given by f of x equals, and then we have a times the quantity x minus h quantity squared plus k, where a does not equal 0. Alright, so the graph of f is a parabola whose axis is the vertical line x equals h and whose vertex is the point h comma k. Fun stuff there. What we need to get out of this is that we have h comma k. That's my point I'm concerned about. So that gives me my vertex, which is really important here. H is my x value and k is my y value. Don't forget that this is a negative, so if I have a positive inside of here for the h, that really means that my graph is shifted to the left. Some general things down here. If you have a value of a that is greater than 1, it produces a vertical stretch, so the graph goes up faster. If it's less than 1, the graph is more spread out for the parabola. And then likewise, if you have a negative value for a, it flips the graph upside down. Alright, so we want to sketch the graph of y equals negative 2 times the quantity x plus 1 squared plus 1. We already know that this is in standard form. What I want to do here is take a look at what the graph of just the function f of x equals x squared looks like. This gives us a good reference point. So that's going to have points here at 0, 0, at 1, 1, and 1, negative 1, and then at 2, 4, and negative 2, 4. And if we connect these, I have a very symmetrical, perfectly drawn parabola. So I want to take a look at what's going to compare to that. So a couple things. We can start with trying to figure out where my vertex is at. So I have the point H and K are here. So I know that my vertex is going to be at negative 1, comma 1. So that's a good start. I have that point, negative 1, comma 1. I'm shifted 1 to the left. Excuse me, negative 1, positive 1 would be here. Over 1, up 1. Alright, let me get rid of that point. I also know that I have the negative, so it's going to open down. If I didn't have the 2 here, this value I would be here and here, but this 2 stretches it vertically, so it's going to go up twice as fast. So I'm actually going to be here and here, and I can sketch it from here. Alright. You could check values to accurately figure out where each of these lines at, but for the sake of this, knowing that this 2 makes it a vertical stretch is close enough for us here, and we can always do it relative to the graph of x squared. Alright, so we want to sketch the graph of another quadratic here, quadratic because of the x squared term. The only problem is this is not in standard form. So my goal is to write something that looks like f of x equals a times the quantity x minus h squared plus k. Alright, in order to do that, we've got to have this part here, x minus h squared. So that's going to require a little work. First thing I'm going to do is factor out a 2 from the first 2 terms. So I'm going to have 2 times x squared plus 4 plus 7. Now I want to be able to write this as a quantity squared. So in order to do that, you're going to do the favorite thing from last year, completing the square. Remember, if I want to complete the square, I take this term here and I divide it by 2 and I square it. So 4 divided by 2, quantity squared, gives me a value of 4. That should be an x here, excuse me. Alright, so it should be plus 4x plus 4. Unfortunately, I can't just add a 4 because I feel like it. So in order to balance that out, I'm going to have to also subtract 4. So plus 4 minus 4. And now I've still kept the same equation. This is part of the steps of completing the square. Alright. I don't want that extra negative 4 in there, so I want to take it outside of the parentheses. So what's going to end up happening is I'm going to have 2x squared plus 4x plus 4, and then I'm going to have minus 8 out here and plus 7. So the question is why do I have this minus 8? Well, it turns out that because of this coefficient of 2, I'm really not just pulling out a negative 4, I'm actually pulling out 2 times negative 4. So then I'm left with this here. If you don't pull out a term, it's just going to be moving this number here. But since I have a 2 out in front, like I said, this is what's going to happen. So don't forget about this. That's a very common mistake. Then I can write this as f of x equals 2 times x plus 2 quantity squared minus 1. Alright, this part is the key here. If what you're left with in the inside of your quantity doesn't factor as a perfect square, you have an issue. Alright, so that's the whole idea of completing the square, and so now I have the form I need where a is 2, h is negative 2, and k is negative 1. Alright. So if I wanted to sketch that, remember we said that I had values of a is 2, h is negative 2, and k is negative 1. So my vertex is going to be at negative 2, negative 1. A is 2, so this is going to go up twice as fast. So I'm going to have something very steep here. And again, you could plug in points and figure out exactly where this goes, but that's close enough for the sake of our discussion. Alright, you're going to do exactly the same thing here. Practice problem 1 is given to you already in standard form. And then function 2 you're going to have to rewrite in standard form by completing the square and then sketch a quick graph of it. Alright, moving on. Example 3, it's a little cut off here, but it says write the standard form for the equation the parabola whose vertex is 1, 2 and passes through the point 3, negative 6. So let's start with standard form here. F of x equals a. It's x minus h. Excuse me. Quantity squared plus k. Alright, so I'm given the vertex, which means this is h and this is k. So I'm going to have f of x equals a times x minus 1 quantity squared plus k, which is 2. I'm also given this point, so this is a unique coordinate x and y, which means I have 6 equals a, which is the only variable I don't have enough information for. Oops. I want to replace that x with a just negative 6. Replace that x with a 3 minus 1 quantity squared plus 2. So negative 6 equals a times 4 plus 2. So we're going to have negative 8 equals 4a, which means a must be negative 2, and so I can use all that information to write it in standard form. F of x equals negative 2 times x minus 1 quantity squared plus 2. That'll be my final answer. This is very similar to finding the equation of a line given 2 points, where you have the slope, you plug in a point, and you solve for the intercept. In this case, we're not solving for an intercept, we're solving for the scaling factor a. Alright. And again, a practice problem here for you. It's the same thing. You're given a vertex and a point. Use the standard form and solve. Good luck.